Assalamu alaikum. Uh, Today on 3rd September 2025, I'm starting lecture number 1 for week number 1. And the topic of my lecture is domain and range of a function. Dear students, as it is your first lecture, so uh, unfortunately it is an online lecture and we have never met before. Therefore, I will try to keep my lecture simple. So on your screen, you can see a line, which is basically bisecting the first and the third quadrant. You can see a red line that is passing through the center of the first and the third quadrant. Many of you will be knowing that this line has an equation y equals to x. Now, if we want to analyze the domain of the function or the range of the function, so first of all, we need to know that what is the domain. So domain of a function is set of all those values that can be used as the input values. For example, in this equation y equals to x, we can input all possible values of x from x equals to minus infinity to x equals to plus infinity. X can take any value. So therefore, the set of all possible values of x is basically the domain of the function. So since there is no restriction, we can put x in the form of integers. We can put x in the form of rational numbers. We can put x in the form of uh, you can say whole number, integers. So there is no restriction. And we can uh, put any value from a very lowest value to a very highest value. Therefore, since there is no restriction, so we can say that we can put x from minus infinity to x equals to infinity, where both minus infinity and plus infinity are not inclusive because infinity is not a defined number. So hence we can say that this line y equals to x, has a domain of minus infinity to infinity, but both minus infinity and infinity are not included. Similarly, if we uh, analyze the range of the function, so what is the range of the function? Range is basically set of all possible output values. So if the equation is y equals to x, then the output values are the values of y. So you can see that the height of this line is not fixed. It could be very low till negative infinity, and it could be very high till positive infinity. So what we can say that the domain of the function, sorry, the range of the function is also not restricted. So it is set of all real numbers which can be written as minus infinity to infinity, where both minus infinity and infinity are not included. So in short, what is the domain of the function? It is set of all possible values of the input variable, which is generally x. What is the range of the function? It is set of all possible values of output variable, which is generally taken as the y variable. Okay, coming to the next slide. Now you can see if the function is y equals to 1 upon x. So it is known as a reciprocity function. And if we draw this function, So you can see that this is basically the graph of the function y equals to 1 upon x, which is known as a reciprocity function. Now you can see that we can put every x in the given function y equals to 1 upon x other than x equals to 0. Why? Because if we put x equals to 0, then the function will become y equals to 1 upon 0. And anything divided by 0 is undefined. So hence we can conclude that we can put any x from minus infinity till infinity, but x equals to 0 is not allowed. So hence we can say that the domain of this function is basically from minus infinity to plus infinity, but 3 points are not allowed. Three values are not allowed. One, x equals to 0 is not allowed, which makes it undefined. And the two other inputs are positive infinity and negative infinity. So other than these three input values, all values are allowed. So it will be the domain of the reciprocity function from minus infinity till 0, but 0 is not allowed. And from 0 till infinity, but 0 and infinity both are not allowed. Okay, so coming to the next slide. So you can see that they have basically uh, written the domain from minus infinity to infinity and the range from minus infinity to 0 and from 0 to infinity. Why the range is so? Because you can see that again, there is no restriction on the height of the uh, function. It could have any height from 0 to infinity, but again, it can never become equals to 0. Okay, so in this situation, the range is from minus infinity to infinity, but 0 is not allowed. So how can we write it in mathematics? So we will write range is such that it is from minus infinity to 0, union from 0 to infinity. Okay. Now this is another function where y is equals to 1 upon x squared. So you can see that this time we can put every x from minus infinity to infinity other than x equals to 0 and both the negative and the positive infinities. So what will be the domain of this function? So from minus infinity to 0, we can put any x other than minus infinity and 0. And from 0 to infinity, we can put any x other than 0 and infinity. So therefore, its domain will be written like domain is such that it is from minus infinity to 0, union from 0 to infinity. Okay, so what about the range? This time you can see that the height of the function or the set of all possible values of y are from 0 to infinity. You can see that there is no y which is below the x-axis. So in this function, since it is 1 upon x squared, so no matter we put x equals to a positive value or x equals to a negative value, due to this square function, it converts everything into a positive y, a positive height. You can see in the graph that there is no negative height. Therefore, we conclude that the height of this graph can be the lowest value of this height can be from 0 to infinity, but both 0 and infinity are not included. Why? You can see as x approaches infinity, the graph becomes closer and closer to the x-axis, but it never touches the x-axis. So hence we can say that the x-axis is an asymptote to the graph, and hence the graph can never touch the x-axis, so it can never achieve a value y equals to 0. In contrary to this, if we consider the maximum height of this graph, so you can see that as we approach closer and closer to the y-axis, the height of the graph increases exponentially. So what happens that at the y-axis, its height becomes infinity, becomes uh, very huge. Okay. So therefore, we conclude that the maximum height could be closer to the infinity and the minimum height could be closer to 0. Therefore, we conclude that the range of this graph is from 0 to infinity. Now coming to another graph, this graph is known as a parabola. You must be knowing this thing from your A levels or higher secondary school education, that a parabola can always be represented by a quadratic equation. Or in other words, we can say that a quadratic equation can always be represented by a parabola. So here in this diagram, you can see that the lowest point of this graph is at x equals to 0, where y is also 0. So this lowest point of the graph is known as the vertex of the parabola. So if we analyze this graph, so we can easily conclude that there is no restriction on the input values. We can put any value of x from x equals to minus infinity to x equals to plus infinity. Therefore, we can say that the domain of this function is from x equals to negative infinity to x equals to positive infinity. Now, what about the range of this function? You can see that the heights of this function start from y equals to 0 till y equals to infinity, because there is no restriction on the height as well. But the lowest height is fixed. The lowest height is 0, but the highest height is not defined. Therefore, we conclude that set of all possible values of y starts from 0 till positive infinity, but the positive infinity is not a defined number, so it will not be included in the set of the range. You can see that when the author wrote the range, he or she used square bracket for 0, because y equals to 0 is possible. At x equals to 0, we can see that the height is also 0. So y equals to 0 is a possible height. So therefore, he used a square bracket. But when it comes to the highest point of the graph, so since it was not defined, so he used infinity for the highest point, but he made a small bracket, which represents that the highest point, which could be infinity, is not defined. Therefore, the range is from 0 to infinity, where 0 is inclusive, while infinity is not inclusive. I hope I clear this point. Now, what about the equation of this graph? So many of you must be knowing that Uh, a parabola, which is a facing upwards parabola, has a general equation y equals to x square. So the equation of this graph is also y equals to x square. And from this equation, you can also identify that no matter x is positive or negative, y will always be positive. So we can say that the set of all possible values of y are basically y equals to 0 or y greater than 0. Okay, so now coming to the cubic graph. So how can we draw a cubic graph? Can anyone draw the cubic graph? Okay, so this is uh, the standard graph of a cubic function y equals to x cubed. And you can see that again, there is no restriction on the set of input values that are the set of values of x, and there is no restriction on the set of values of y as well. Therefore, we can easily conclude that the domain is also from minus infinity to infinity, and the range is also from minus infinity to infinity. And obviously, since minus infinity and infinity are not defined numbers, so both minus infinity and infinity are not included, but all those numbers that lie between minus infinity and infinity are valid input or output values of this cubic function. So that is basically the concept of domain and the range. Now coming to another function, which is known as y equals to modulus of x. Now what modulus function do is basically it converts every negative number into a positive number. Suppose x is minus 3, then modulus of x will become 3. And if x is 3, then it will remain 3. So if there is a negative number, modulus function converts it into a positive number. And for positive numbers, it does not change them. Okay. So how to basically draw this graph? It's a very simple thing. Uh, in the first function that we discussed, if you remember, we drew a line y equals to x. And that line was basically bisecting the first quadrant and the third quadrant at an angle of 45 degrees because a quadrant has 90 degrees. So that line y equals to x was bisecting the quadrant at 45 degrees, both the first quadrant and the third quadrant. Now, this graph is basically the same as it is concerned for the first quadrant. So for the first quadrant, it is y equals to x, the same graph. But for the third quadrant, what happened that the graph was below the x-axis and it was in the third quadrant when the equation was y equals to x. But due to this modulus function, that portion of the graph which was in the third quadrant, which was basically below the x-axis. So that graph is reflected in the x-axis. So what happened that rather than being drawn below the x-axis in the third quadrant, it came up in the second quadrant due to a reflection in the x-axis. Why we did this reflection? Because the modulus function converts a negative y into a positive y. So suppose at x equals to minus 2, y was minus 2. So this modulus function converted into plus 2. Similarly, at x equals to minus 5, y was minus 5 when the equation was y equals to x. But since now the function is y equals to modulus of x, so that minus 5y becomes positive 5y. So overall, what we can say that if the equation was y equals to x, then the left-hand side graph is to be drawn in the third quadrant. But due to this modulus function, because it is not equation y equals to x, rather it is y equals to modulus of x, the graph which was below the x-axis was reflected about the x-axis and hence it became above the x-axis. So a modulus function never gives you a negative value. It never gives you a negative height. Therefore, we can easily conclude that the range of this function is from 0 to infinity. While there is no restriction on the domain, so the domain remains set of all real numbers, which can be written as small bracket minus infinity to plus infinity, small bracket close, and which means that all real numbers are included in the domain other than the minus infinity and the infinity to extreme values. Okay, so what about the range of this function? It is very simple. Y could not be negative in a modulus function. So the lowest possible value of y is 0, which is inclusive, and the highest possible value is not defined. So we will write it like positive infinity. Okay, now coming to another function, which is a very basic function y equals to root of x. And now if you can see, the graph is drawn only in the first quadrant. Why is this so? Because we can't put an input value which is negative, because root of a negative number is not a real number. It is basically undefined. So therefore, a negative x is not allowed. So what we can say about the domain of this function? Its domain starts from 0 till positive infinity. Every number is included, but since infinity is not defined, so we will write it like square bracket 0, comma, infinity small bracket. Why is this so? Because 0 is inclusive. 0 is a possible answer. When x equals to 0, y equals to 0. So we can put in values of x as 0. But the highest value of x is undefined. So it is infinity, which is not a defined number. So we made a small bracket after infinity, which confirms that every real number from 0 to infinity is included other than the positive infinity, which is not a defined number. Similarly, what about the range of this function? You can see that the height of this graph starts from y equals to 0 till y equals to infinity. So therefore, we can say that the range is from 0 to infinity. And since uh, you can see that positive infinity is not a defined number. So therefore, what we will do, we will make a small bracket for positive infinity because it is not a valid answer of the output value. Okay. So it is basically named as the upper half. Now, again, it is a very important function from engineering point of view, which is the graph of y equals to ln of x. Now, what is y equals to ln of x? Actually, for this, we must be familiar with the logarithmic function. Actually, when we calculate log of a number, then we are basically interested to find that which power of the base is equals to that particular number. For example, when we calculate log of 100, then in actual we are interested that which power of 10 is equals to 100. So if we uh, use our calculator to calculate log base 10 of 100, then the answer will be 2, because which power of 10 is 100? So power 2 of 10 is 100. Therefore, we will write 10 squared equals to 100. So when we will calculate log base 10 of 100, we will get an answer of 2. Now in the ln log, the base is basically a famous number, which is E. 2.7172 is a good approximation of that number E. Now y equals to ln of x means that we need to draw a graph between ln of x and y. So at x equals to 1, it will become ln of 1, which means that which power of e is equals to 1. So obviously, since e power 0 equals to 1, so you can see that at x equals to 1, y is 0, because ln of 1 means e power 0 is 1. So therefore, at x equals to 1, it is ln of 1, which is 0. You can confirm it using your calculator. Similarly, why this graph is becoming very closer to negative infinity at x equals to 0. Because uh, if we take, suppose, example of log, then log of 0.1 is minus 1. Now, if we make x closer to the y-axis, suppose it is 0.01. So log of 0.01 is minus 2. Similarly, if we increase another 0, log of 0.001, then it will become minus 3. So as we approach closer and closer to x equals to 0, ln of x or log of x becomes closer and closer to the negative infinity. So as we approach at x equals to 0 from the right hand side, which is known as the right hand limit, the graph approaches negative infinity. So you must be knowing that ln of 0 is negative infinity. It is a very important concept in limit theory, that what is ln of 0? It is not simply undefined, it is undefined and mandatorily negative equals to negative infinity. Okay. Now you can see that in this graph, there is a restriction on x. X could not be equals to 0, because at x equals to 0, we get a negative infinity answer, which is an undefined answer. So we can't input value of x as equals to 0. Similarly, you can see that in the range, there is no restriction. It could be negative infinity, it could be positive infinity. So therefore, since there is no restriction on the set of output values, so we can say that all possible output values, all values of y are possible, all real values of y are possible from negative infinity to positive infinity, where both the negative infinity and the positive infinity are not inclusive. So that was all about domain and range from my side. If you want to ask any question, you can ask it right now. No answers? So inshallah, we'll meet you in the first on-campus class in the next lecture. Till then, take care and Allah Hafiz.